All right, so that's next week. So here we are with this week. And, I've scaled back a little bit the amount of material to cover. Partly it's getting more, it's a little bit more difficult material with the list processing and now two-dimensional lists. And there's something else in this, I can't remember what, in module 3.7. But, and partly there's, a certain number of people that are falling behind or having to spend, a fair amount of time on getting some of these assignments done. And I really don't want to leave too many people in the dust. So I decided to slow it down a little bit. And we will be finishing module 3 tonight and then just starting into module 4 next week. And I haven't published that yet. So you haven't been able to see that. I just turned it on so you can see it now. So I'm jumping ahead in module 4 because I thought it was a little strange for them to cover variables and then lists and then jump to functions and then come back to another type of data structure, which is tuples and dictionaries. So I wanted, since we just are finishing up lists, I wanted to continue with talking about additional types of data structures before we jump into functions. So that's what 4.6 is tuples and dictionaries. We're not going to work too much with dictionaries in terms of the threaded assignment, or I might have an assignment here and there. So tuples is really the more important because that does factor into what you have to do for the threaded assignment. Tuples are really simple to grasp. I think they're very much like lists with just some small differences, and they're in fewer methods available for tuples. So there's not as much to have to absorb. So all right, so that's where we're at. So we've got just two assignments, and then the quiz and the test. And I apologize, I mentioned it on the Zoom session last week that I was moving the quiz and the test to this week. And I actually did move it into the week 7 module, but I didn't change the due date. So several of you I saw did the quiz, but you all got 100%, so no big deal there. But those that did the test, I can't remember if it's set to automatically let you have another shot at it, or if or not. But I'll look at that. And anyone, basically, I'll take it on a case-by-case basis. If anyone that already took the Module 3 test and isn't happy with their results, I'll let you do it again, because I didn't intend for you to have to do it last week. So there was a few of you, I don't know if some of you that are here and maybe one or two that aren't here, that did the test, and the results were from excellent to, decent, but some of those that were on the decent side as opposed to the excellent side might want another shot at, especially after we talk about list comprehensions. That was the other thing, list comprehensions and 2D multi-dimensional lists. Because some of the questions in that test, actually a good number of them dealt with list comprehensions and multi-dimensional lists. So you were a little bit at a disadvantage if you already took the test. Okay, so I guess I think, yeah, I'll stick with what I did last week and cover the 3.7 material, and then and then I'll ask about if any people have any questions with the week 6 assignments, or if you've looked at any of the 2 assignments here, whether you have any questions about what's expected there. So I'll start with the 3.7 and take it from there. I think it's a fairly short module. I'm a little, they were, the Python Institute curriculum was, pretty good about having a good number of labs in the early modules, and they kind of sloughed off towards the end here in module 3 and again in module 4 with labs per topic. So, I'm gonna have to make up some additional assignments because you really have to do problems using the new aspects of the language or new aspect of programming that you've just learned. Otherwise, it just doesn't tend to sink in. So let me get to 3.7. Yeah, they just don't have a lot of labs. Well, they have one in here, and it's a rather complex one with, creating a basic, what's it called? My mind is going. What's the little tic-tac-toe game? And I thought that might be a bit much for a lab assignment, but we'll see. So, so multi-dimensional lists, basically having a list inside of a list. Another way to look at it is a nested list is another way you'll hear it. So let me bring up an example I've got somewhere in here of some list comprehension. If I can find it. List, there we go. Well, let's talk about list comprehension first, but it's pretty close up here. So what they start off with talking about here is, just essentially making, starting the process of making in this case, a chessboard. And this term white pawn, that would have to be defined somewhere, because you can't just use a term that isn't defined. It's obviously not a keyword in Python, so you'd have to define that, and they don't bother doing that. They're just using it as an example of, you're adding something to a list called rows. And now they're showing you how to do the same exact thing, except on with a single line of code. So in this scenario, when you use a for loop, you need to initialize your list to be an empty list, and then have your for loop, and then append whatever you're supposed to append within the for loop. The slicker way to do it, and the Pythonic way, is to use a list comprehension. And from the example, from the programs I see online when I'm looking for examples of something that involve lists, that's pretty common, using list comprehensions. So as you can see, you can sort of get the idea of what's going on here, but we'll just break it down. So to to start off a list comprehension, you have to, specify the left bracket saying that this is a list. And then they're basically saying, here's the element that I want to put in the list. And then here's my for loop. Okay, so it looks a little bit backwards or strange, but that's the way it works. So this right here, this whole statement is 100% identical to those 3 lines of code. Does the exact same thing. Okay, it's not necessarily more efficient. It's something you'd have to do some testing with to see if a list comprehension is more efficient programmatically than doing it the good old-fashioned way. But it's the Pythonic way to do it. And if you're going to initialize a list from data that is in your program, then that's probably the way to do it. And they give you a couple more examples of list comprehensions, putting all the squares up through 0 through 9, the squares, squared values 0 through 9 in a list. So again, x squared is the value they're putting in each element of the list, and in this case, that element changes for each iteration through the for loop. So the first time x is going to be 0, so 0 squared obviously is 0, so that first element of that list will be 0. Then x will be 1, and 1 squared is obviously 1, so it'll be 1. And then the next time x will be 2, and 2 squared is 4, so the next element will be 4, and so forth. So might as well just put it in here and run it in Sandbox so that you see, oh, that's right. I keep on thinking this is like a normal console where I can, tell it to show me the contents of a variable from the program, but it is not. So I have to add print statement. All right, so you see 0, 1, 4. So those are all the squares from 0 through 9. And, to further make it even more complex, you can even put an if statement. Okay, so in this particular case, they're creating a list, and now they are, going through another list, the squares list that gets created. So I'll add this up to this code here. So x, again, x is the element that goes in the list, the new list called odds. And it's basically say for x in squares. So if that was the end of the statement and you didn't have the if here, if that was the end of the list comprehension statement, then it would just go through each of these elements and you would create a copy essentially of the list squares. And that's an inefficient way to make a copy. So in this particular case, they've got an if hanging out after the for statement. And so that changes, they're only going to put the element x if x mod 2 isn't 0. In other words, as long as x isn't divisible by 2. So it won't put the 4, it won't put the 16, it won't put the 36, and it won't put the 64 into the odds list. And that's why it's called odds, right? It makes sense. That's why they named the list odds. So that's for the first list, and then here's the odd squares that is generated from that statement. Okay, are you following this? Pretty good? Okay, so let me just bring another example. Doesn't hurt to look at multiple examples. So this is how you would create a list that consists of a bunch of numbers. You know, in this case, 0 through 9. All right, and the list comprehension way looks like so. So I'm going to run it with the list comprehension one uncommented out, and you'll see that we get 2 identical lists. Okay. All right, so that's list comprehensions. You know, really, it just takes following the code that's inside the brackets, and you know, it should be able to get it. Now, when it becomes where it becomes a little bit harder is when you've got 2-dimensional lists. And so here's one way that they are creating this board. Remember, they initially they were doing this chessboard, and they used pawn as the element. Now they're just using empty. Really, we can actually run this. Using empty would throw an error. So there is an actual, essentially a substitute keyword in Python for empty. Anyone know what it is? If I wanted to fill up this list with elements, but I wanted each element of the list to essentially be empty, have nothing in it whatsoever. Any idea what I could empty is not a keyword, so that this would throw an error.
Would it be none or
none.
null?
Yep, none. Okay, as you see, none gets highlighted or gets put in blue, telling you it's a keyword. And whereas empty, wasn't. Whoops, empty is not a real word. So, and just print. So in this example, they are doing a for loop, an outer for loop, and then they are within the for loop, they're creating each row of the chessboard. Okay, and then they are appending that row. And this is really very inefficient because they should just create the row outside of the for loop and just do the append 8 times. I'm not sure why whoever wrote this did it this way, but nonetheless, it'll still work. So each time through the loop, list comprehension to create row, and then append each row to board. So we're basically going to have 8 rows within the list called board, 8 rows that say none. Oh, good. So told you that every once in a while this happens where Sandbox craps out on you. I'll try it again. Yeah. Okay. So
same thing happened to me when I tried running it. Yeah. So it's going for everyone.
Okay. So we won't do it in Sandbox. I'll do it in Thorny. I'll have to save it. So we'll just say a 2D. Okay, so as you see, there's an outer list, that's these outer brackets here. And then there's 8 inner lists, which have the same, are all none. That's why I said inefficient to do it this way. There's no reason to do the list comprehension 8 times, since you're just overwriting the list row every single time. So it should be, if you were going to do it this way, it should be brought outside the for loop and produces the same thing. Yeah, never put in a for loop something that just does the same thing over and over and over again. And if you need to initialize something, like in this case, the list called row, it needed to be initialized with 8 nones. You put it outside your for loop, and then your for loop just creates that larger list. And now, of course, they're going to show you how to do this with a list comprehension. So that, that code gets replaced with a single line of code. So the rightmost for loop in the list comprehension, in the brackets, is the larger list. So that's essentially your board, the thing that creates the board. And then this inner list, and of course, again, it's got the brackets, that creates the rows. So if we, copy that code and put it back into our program, all right, so now we're not creating that intermediate list separately. It's being created each time this outside loop executes. And you'll see that you got the exact same thing, except what happened here. Oh, I got to replace empty with none. So exact same thing. So that's it. That is list comprehensions. You could do it, 3 levels if you wanted. I guess as many levels as you want. I don't really know if Python has a limitation to how many dimensions a list can have. Working with more than 3 or more than 2 is sort of uncommon. I can see a need for 3-dimensional lists here and there, but working with 2 is a fairly common thing. I work with 2-dimensional arrays in programs that I write on a regular basis. So, okay, so you understand list comprehensions. Well, first off, you understand nested lists, just list within a list, and then how to create them with how to create lists and multi-dimensional lists with list comprehensions. Okay. All right. Okay, so the rest of this is really just following up on the idea of creating a chessboard, so you can create your computer against human chess game. Creating the board is the easy part. Creating the logic for how the computer makes its moves and checking the human to make sure they're making valid moves, that's the hard part. But in any case, that's, I guess that would be one application of using multi-dimensional lists. Oh, I guess another thing to look at is how do you address the various elements of a multi-dimensional list. So let me bring Thorny back up here. And let me put something in here different than none so that we can see the values. So let's just put J. Is that work? Let's see what that looks like. All right, so that's just creating lists within lists again, starting 0 to 7 because initially J is 0 and then I goes from 0 to 7. So that's why we get that. And then J is 1. And so we're adding 1 to 0 through 7. And then J is 2. So that's why the start of the list and the end of the list are creeping up by 1 value each time through. But the main thing was to demonstrate accessing an element of the list. So what number is going to come out of that particular reference to board? Anyone? So which element am I referencing in this multi-dimensional list?
The second and third list?
What's that?
Would it be the second and third list?
Well, this is gonna just reference a single element. So it's gonna reference one of these, a number that's in here, the 7 or the 6 or 2 or the 0. So what number is it going to reference? You know, what number is going to be shown when I hit enter, and which, you know, where in this two-dimensional list was that number found? Is the question I'm asking. So
5.
remember, what's that?
5.
5. Anyone else?
I mean, it's a guess, right?
Yeah, it's a guess.
Three.
It happens to be a wrong guess. I hear
3.
I hear 3, Chris?
Yep. Yeah.
3 is correct. Which 3? This 3? This 3?
I'm gonna be honest. I did it in Thony and gave you the answer. I have no clue.
Okay, so the first subscript, the one here, says I want the one index of the larger list. Okay, so this is the 0 index. This list here is the let me show you that. Okay, so board 0 refers to this entire list because that's the essentially 0th index value of the board list. Okay, so if I do that, it's going to show me that list I just highlighted. Whereas board 1, well, let's go all the way to board 7. Board 7 is going to give me the very last one. Okay, so now when oh shoot, let me print it again. So now when I say board 1, 2, this subscript is referencing the element within this list. So board sub 1 references this list, and the 2 index value of that list is 0, 1, 2. Is that 3? So yes, 3 was correct, and you know, you got the right answer. You just didn't know how it was right.
But now I understand it. So
Okay,
if we had 3 nested lists, we could do that with 3. Then we could do board 1, 2, 3.
Yep. So now what does board 3, 4 give me?
7.
and which, go ahead, Chris.
7.
6.
Okay, 7 is right, because board sub 3 is this list, and then the zero
No.
element, the first, the second.
That's the
Oh,
fourth list.
Did someone say 6 or 7? 7. Someone said 7, right?
I said 7.
Yeah.
I said 6 because that's the fourth list. We're looking at the third list.
Yes, we're looking at the third list. So it would be this. Right?
No,
No, you're right. 0, 1, 2, 3.
no.
0, 1.
Don't forget this.
Oh,
3.
0. God
Yeah.
dang it.
Yeah, remember everything's indexed by 0. Okay. Thought that, yeah, so I get it wrong.
You're not going crazy. I'm
Okay,
just
so 0,
slow.
1, 2, 3, 4. So it's the, essentially the fourth list if you start from 1, but if you start from 0, it's a third. So anyway, it's this one that we're accessing, and the fourth element is going to give you 7. Okay. So yeah, this whole index by 0 does get confusing, but that is really the way that the vast majority of languages do it. There's a few languages out there that decided to do indexing of arrays and strings and stuff by starting with 1, but those are mostly like BASIC and some scripting languages. So most of them do it by 0. Okay, so you're getting that, how you reference individual elements within the list? Because there's going to be questions on that exam 3 that some of you already know that you're going to need to know how to do this. It gets pretty confusing. I'm going to actually go through some questions like what you'll see on the exam. And I'm going to try not to duplicate them exactly, but that way you'll have an idea of what you're up against and what you need to practice. Okay. Oh, let's another thing. What happens if I reference? What if I do this? Is that even legal? And if it is, what number, what element is going to show up?
13.
13. Correct. -1 says the last element of the larger list. So that's this inner list. And then -2 says the second to last, right? So here's another one, and this pertains to slices. Well, let's do this. Let's do, I'll just do a simple index. Board 4, and then let's do okay. So what is this going to return? First off, is it going to return a number, or is it going to return something besides just a single number like these guys did? Is it going to return
8, 9, 10, 11. They'll show a range.
I haven't even looked to see. So -4 is going to be 1, 2, 3. So it's going to be this. And then, yes, you're close. Okay. So -1, -2, -3, -4 will be 8. So 8, 9, and 10. The reason that you're not going to get 11 in there is because, remember, slices are different than just using a simple index value. The second value in a slice says up to but not including that. So this says starting from the fourth element from the back, which 1, 2, 3, 4. So this list, right? Starting from the fourth element from the n, which would be the 8, up to but not including the last element. So 8, 9, and 10. Okay, and so that's something that I forget about that sometimes, but you're going to need to know that for the test. Let's put it that way. That when you have slices and you've got that second number, that second number is up to but not including that index value. So -1 means the last. So it means up to but not including that last element, which was the 11. So up to but not including that. Okay. Just some little tidbits that hopefully will help you out in the test. All right, let's. Oh, I'm not sure if there's anything in here that I wanted to particularly go over. This is just kind of using, using lists and applying them to, some potentially useful situations. But there's nothing, there's nothing new here. They're using stuff that we've already covered. They're just, essentially showing you, this is a cool way that you can use lists. In this case, they're storing the temperature for every day of the week or something, or month or something like that. And then showing you the highest day of that month or something. Which, you could do that in a program, that had a sensor that was actually collecting temperature data or something, unless somebody was manually entering it. Okay, so again, these examples don't have anything new in them that I can see. If there's anything that you see or that you saw when you went over it that you need some clarification on, then just let me know. Here's an example of the three-dimensional list where it's like a hotel complex where there's buildings, floors, and rooms. So that's why they need 3 dimensions. So the outermost list is the building. The next level list is the floor within the building. And then the most inner list is the particular room in the building. So, using a 3-dimensional list like this in a program, if you were writing a program for a hotel to manage their room occupancy, or whether the rooms were cleaned or something like that, you could use something like this to manage that. More than likely it's done in a database, but the database is probably read into a list of some sort like this to be able to work on the data. Because with databases, you normally don't work on the data directly because it's sitting in a file somewhere. So with databases, you read the data in to a structure of some sort, like a list or whatever, and then you change, you massage the data, and then you write it back to the database. Okay, so that's what this is giving you an example of. Again, there's nothing new here except just another level dimension to the list. All right. All right, and that's the end of that section. So big takeaways were multi-dimensional lists and then creating lists using list comprehensions. And then, as always, check your understanding here. I actually just used a multi-dimensional list in a program that I was working on. So in what it was storing, instead of putting list within lists. So it really wasn't a multi-dimensional list, but it was similar to a multi-dimensional list. Instead of putting lists within lists, it was putting tuples within a larger list. And as you'll see, once we start section 4 and you read 4.6, a tuple has some of the same properties of a list, but you'll also see there are a few differences. So yeah, a tuple is essentially, in most cases, it's two or more, usually two or more elements of data, or two or more elements of data that may or may not be of similar data. My program that I was using, it was holding a URL from a website and a timestamp. The timestamp was telling me, when that URL was last had something in stock that I was looking for. And that way, my program sends me a text every time something's in stock. Well, I was getting texts every 20 minutes because I was just checking to see if they were in stock, and if so, text me. All right, and I was like, no, yeah. When they were coming at midnight and 1 o'clock, I said, okay, I think I need to adjust the program, and so I added a timestamp to things to say only if if it's been more than a day since you last texted me, should you text me again about this element. Okay, that is section 3.7. So like I said, pretty short, but it does have some of the more complicated or complex things that you're going to have to work through in the test. And like I said, I know some of you have taken it, and at least a few of you did really well. If you're here, and like I said, I don't remember exactly who scored what, but I know there was at least one 100 and a couple of 90s and stuff. So, but I am going to go over a couple of things that you might need to understand when you're looking at the problems in the exam. Okay, so let's take an example here. Actually, I'm not going to do it. I'm going to say L1, make it easier. So I'm going to take a list, create a new list, and then I'm going to, and this might actually be exactly from the test. So here, it'd be easier if I copy and paste. So I already typed this once. Okay. Okay, so I've created. I created this list, L1, with 3 elements in it, and then I did this command. What's that command going to do? What is my new list going to look like?
Going to replace 0, 1 with 1, 2. So the list would look 1, 2, 2. Is that correct?
1, and then 1 gets replaced with 2. So, but element 0 goes, so it's swapping element 0 and 1. So the 1 and the 0 get swapped. And then also element 1 and element 2 get swapped. So the 0 and the 2 get swapped. So I think it's going to end up as 1, 2, 0. 1, 2. I'm sorry, 1, 2, 2. So 0 and 1 get swapped. So you end up with 1, 0, 2. But then element 1 and element 2 get swapped. Actually, it happens at the reason that the 0 went away, so it must happen simultaneously. Doesn't. Huh.
So was I right?
That's
That's why I said 1, 2, 2.
Oh, you did say 1, 2, 2. Okay.
Yeah.
You were absolutely right because it's there. I think what I meant to do is this. Whoops. Swap 0 and 0 and 2. Okay. So yeah, you were right. What does this one do? I'm sorry, assuming that we start with the original list. Now, we want to swap 0 and 2. Okay, so what's that going to do?
2, 1, 2.
210.
It essentially is going to reverse the list, right? In this, only because it's only a 3-element list, it reverses it. Doesn't change the size of the list or anything like that. The list is still the same size. All it does is essentially just swap those 2 elements. Okay, now let's look at this. Make this console bigger. So we create a list and we do this assignment. And we do this. Okay, so what is inside the nums list? What's inside the vals list? Anyone?
That vowel should just be 1. I think on that one. If nums is equal to it, then both should just have 1.
Right. They'll both have 1 in it. And so why is that? All we did, we initialized nums to be an empty list. We didn't do anything to it. We didn't change it in any way. We only changed vowels. So why is nums have the same, why does it look like we did a nums.append 1 when we didn't?
It's the same variable.
They're pointing to the same place, right? With lists, when you make an assignment like that, list equals list, you're not making a copy of that list. Vowels and nums point to the exact same list in memory. So anything you do to nums happens to vowels. Anything you do to vowels happens to nums. So if I append to nums, now we have 1 and 2 in both of those. Okay, so that is a peculiarity of making an equivalence or an assignment of one list to another list. Now, if we've got them both equaling 1, 2. What if I now say and then I do so what does vowels have in it? What does nums have in it? Or do they both have the same thing?
Vowels has 1, 2, nums has 1, 2, 4.
So when you do this using the slice operator inside the brackets, you're saying, I want to take each element from the vowels list, starting, because when you have no starting number, no ending number on either side of the colon for the slice, which is the slice operator, it means 0, element 0 all the way to the end. So it means the entire list. So when you take a slice, from one list and assign it to another list, you're making a copy. Now nums and vowels are totally independent of one another. Nums changed because of the append, vowels didn't. All right. How about if so we know what nums looks like. What if we do insert? Oh, this is. So what does nums look like now?
6, 1, 2, 4.
Okay, so the insert says, literally insert this element, which is the number after the comma, insert it before position, whatever that first number is. So that's saying put it at the beginning of the list. Okay. So, and then, I can also do if I do that, it's going to put it before the 2 index value, which will be, so it'll look like 61624. Okay, so this is what I was actually hoping that somebody in the class, that this is the method that they would use to reverse the list in that one assignment. Instead of, some people went ahead and did the algorithm to essentially reverse sort the list from that lab assignment. But I was hoping, because right at the end of last Zoom meeting, we talked about the insert method, and I was hoping you'd catch on that all you really need to do is when you are creating the list in that assignment, instead of using append, you use insert in front of element 0, and it'll naturally reverse the list.
That would be too easy. We had to take the long way around.
Some of you took the even easier way out and did the is that what the syntax is? No, that just takes slice.
It's a double colon, right?
Right. Yeah. you're right. I wanted the step value.
Weren't we asked not to use that?
I did, but not everybody was there. And I meant to, after our meeting, to go and change the instructions. And I didn't because it was late and I was ready to leave. So the couple that used that method to reverse the list, now you couldn't, I specifically said in the instructions, you can't use the reverse method. I don't know if it's anyone here, but some clever person didn't use the reverse method. They used a version of the sort, which this is an option with the sort method. You can say reverse equal true. What did I do wrong? What is it then? That's not that. Huh. I could have sworn it was capital R.
Is it reversed?
Reversed. Okay. Maybe that's right. Unless it's lower.
Psych.
Yeah, it's lowercase r. Yeah. So someone. What?
2 equal signs?
No, it shouldn't be.
Is it dot reversed or something? Yeah.
Let's see. Now I'm curious because whoever did it, and I never have used that in my life because I know that the reversed method works. So I'm going to see what the syntax is. I'm pretty sure that I ran their program. Reverse equal true. Sort the list descending. So what did I do wrong? Reverse. Reverse equal true. Oh, I don't know. I must have done something. I never tried it with lowercase reverse, maybe. Anyway, so that's the syntax. And since I didn't specifically say that you can't do it, I let them have it for being resourceful. I don't know. Was any of you here that did this method for reversing the list? No. So yeah, I learned that, sometimes I've got to be a little bit more explicit in the direction, so or people will find interesting ways to do things that I wasn't expecting. Okay, so let's look at a couple other things that you need to know about. And okay, we know about list comprehensions. Okay, so here's I'll just write it down here. Oops. All right, so there's a list. And what is that gonna print?
One.
Nothing. There's a space between print.
That's allowed.
One.
White space is allowed between the function name and the function. I think. I mean, I'm pretty sure it is.
Is the answer one?
The answer is okay. So how did we get to that? Let's look at what list -1 equals. Because list -1 here, that's being used as the index into list 1, right? So, whoops, list 1. So that equals -2, right? Because list 1 -1 means the last element in list 1. So essentially this resolves to -2. And so what we end up having is list 1 -2 index. So if I could spell it right. So that's this right here is exactly the same as this. And so -2 points to the second to the last element, which is the 1. Okay. So these are, I'm just telling you, these are the things that you're going to find on that test for those that haven't already looked at it. Let's see. Let me get some others. Oh yeah, here's I'm going to change this up a little because I think it's too close to what the actual test had. Where did it? Okay, yeah, I'm going to change it up. I'll be right with you. So, oh, it's not going to like that. Where's that exclusive or hiding? There it is. Okay, so what is it going to print? Okay, so we know
0,
that
1,
101.
1, 0, 1.
this is just a number, a single number is all it's going to print.
So
It's
2.
adding up the value of C, D, and E together. So let's look at this. A is 0, B is 1. C is A or B, so what does C end up being?
1.
Right, so C is 1. D, C is 1. D is A and B, so what's D equal?
1.
Remember, and when you and a 1 and a 0 together, what do you get?
0.
0. And only produces a 1, because remember, this is a bitwise and. And only produces a 1 if all the elements involved in the and have a value of 1, okay, or true or whatever. So D is going to equal to 0. E is A exclusive or B. So exclusive or A and B. So what does E equal?
0.
Now exclusive or,
1.
right. The only exclusive or gives 0 when both elements are 0 or both elements are 1. So yeah, so we have C.
I had a 50-50 shot, right?
So E equals 1. So if we print out C, D, and E, we get C we just determined was 1, D was 0, E was 1. So 1 plus 0 plus 1 equals 2. And I actually had meant to change that. I think that might be exactly from the test. So anyone that remembers that, you get a freebie. Okay, let's look at some logical ands and ors. All right, so what's that going to print? Let me fix the spacing a little. So y, x is 5, y is 10, a is true, b is false. So what is this going to print at the end? So something like this, you take them one by one, and you have to remember that and statements bind tighter than or statements. So that means that the and here is going to be done first, and then this is going to be done, and then the or of those two. So the or between this result will be a true or a false. This result will be a true or a false. And then the or is done between the two. Okay, so y greater than x is true, right? So we get true and a, which is true. So we get true and true. True and true equals false equals true. Okay? That's the only time when and yields true is if they're both true. So y is greater than x and a is true. So we get a true there. Now, if you were on the ball and you had a problem like this, and you know that the or is done last, then you're basically done with this problem. Because if either side of the or is true, then it's true. It doesn't matter at this point what this ends up to be, because you've determined that this is true. So we don't care about this, because whether it's true or false, the entire statement is going to end up to be true. Okay, so that if you have a test problem where you've got an or in there, then and it's and there aren't parentheses to change the order in which things are done, then you can use that to your speed advantage. Okay, now how about this version? Okay, so now I've changed things up a little bit by using parentheses. So that means that since this whole statement is in parentheses, this whole statement has to be evaluated before the and with this statement will be evaluated. So y greater than x is true, and a, which is true, or b, which is false. So we basically, because the and binds tighter than the or, since this is true, we get true or false, which still ends up to be true. And x greater than y. So this statement is true, but it's anded with this statement. And x
So it'd be
greater than
false.
y is what? False. So we end up with true and false. Since they're not both true, and always yields false. So that's going to end up false.
Yeah, I noticed on the debugger when you run the or, it doesn't even look at the other side of the or, right?
Right. It doesn't look at the other side. If the left side of the OR evaluates true, then it just blows off the other side of the OR and continues with the rest of the problem, because yeah, it doesn't need to, since if one of the elements is true, then the whole statement is true. Okay. All right. So you'll have something like this, not exactly, but something like that. So let's look at another one. Here's where you have to trace a program, and you're going to have to figure out how many times something prints. And again, I don't know how close this is to the actual program, the actual problem. If it's too close, let me make sure. I've got the test up here, so. Oh yeah, I've got a little bit different.
What's the time limit on these tests?
30 minutes for 20 questions.
30 minutes for 28 questions?
20.
Oh.
So, and from what I can tell, I mean, some of them you're gonna want to take a little time with. You just can't take, more than a minute and a half average for the whole test for each question. So the ones that are, these longer tracing problems like this, you want to take your time because they're a little bit tricky, I have to say. Okay, so let's just trace through this before we run it. So x is 1, while x is less than 8. So we're going to increment 1 each time at the beginning of the loop. So x is now 1, or x is now 2. And then it says if x mod 2 equal 1, then continue, which means continue means don't execute any more statements in the loop, just go back up to the beginning of the loop. So in this first instance, we started off with x being 1. And here, let me put because literally if they're difficult ones, this one wasn't so difficult for someone that's done it a lot. I write it down on a pad of paper and trace the values. So x is equal to 1 at first. Then x is equal to 2. If x mod 2 equals 1, well, the mod will equal 1 only if it's not an even number, right? Because x mod 2 will always yield 0 if the number is either 0 or divisible by 2. So that means, since we're looking for it equaling 1, that means we're looking for an odd number, something that 2 doesn't go into evenly, because we want a remainder of 1. So in this first one, we don't continue because x equals 2, and so 2 mod 2 is equal to 0. So this statement's false, so it does the print. So we do one print. Now we go up to the beginning of the loop, add 1 to x. X is now 3. X mod 2 equal 1. That's true, so we continue and we don't print. Go back up to the beginning of the loop. X is now 4. X is now 4. If x mod 2, so 4 mod 2 is not equal to 1, it's equal to 0. So it doesn't continue. It goes ahead and executes that statement. So it prints another pound. Goes back up to the beginning of the loop. X is now going to be 5. 5 mod 2 is equal to 1, so we do a continue, not a print. And so you can see where this is going. Now you can basically say it's going to, when x is now equal to 6, it's going to print. So whenever x is even, it's going to print. Whenever x is odd, it's not going to print. So when x is 7, it doesn't print. And then since it says less than 8, well, x is still less than 8. So we go one more time through the loop. X is now equal to 8. And 8 mod 2 doesn't equal 1. So goes ahead and does the print. And unless I screwed up while I was talking, it should print 4 pounds. Is that correct?
I got 3 in my head, but we'll see.
Yeah, maybe. Let me just do it in my head real quick, because sometimes when I'm talking and typing, I oftentimes screw up. So
It's 4. I tested it.
yeah. What's that?
It's
Did you
4. I ran it.
It's 4. Okay. So I didn't screw up. So 4 pounds. Okay, so you're going to have a few of these, and both of them actually have a mod, I believe, in the if statement. So just remember what the mod does. You're looking for what the remainder is. And, you know, if you're really quick with the typing and stuff, I'm not telling you to do this, because if you were in my classroom doing these tests, you wouldn't be able to, you know, I'd be walking around making sure you're not typing the program in to see what the actual results are. I can't do that at home, so I'm not going to say don't do that, because I can't enforce it. But 30 minutes gives you, you know, not a lot of time to type stuff like this in and get it right without typos. So if you're going to do that, do it wisely on the ones that you really are having a struggle with. Okay, so let's see. Let's look at another one. All right, how about this one? Oops. Okay, so what is L1 look like? So what's going to print out there? What does L1 look like by the end of this? And this actually might be a good time to use the debugger again to step through this. How do I clear that window? Okay, so we'll just step over the assignment there. We know L1 is equal to that list. And we'll step into the for loop. So the range is going to be what? What's the range? The length of L1 is what? What's the length of the list? It's going to be 2. 2. So this loop is going to iterate 2 times. With values 0 and 1 for x. Okay. So x starts off as 0. And so we're going to insert into L1 before the first element L1 sub x. L1 sub x is 0, so L1 sub 0. Okay, so it's going to essentially insert in front of the first element, the first index element, the value 0. Okay, so it put a 0, added a 0 in front of the 1. Okay, now x is 1. And what's it going to insert next?
another 0.
Well, it's going to insert L1 sub X. X is now 1, so X is going to be pointing. Oh, yeah, you're right, because the list has changed. So it's now pointing to 0. Okay, go through that. So it's going to put in front of the first element, which is a 0, another 0. Right? So when you're tracing these through, because this is another one that would be, it would be hard to do in your head. And because there is one, there's a couple like this where the list is probably at least one element longer than this. So it'll take a little bit longer to, go through it. So, when you're going through this, make sure that you write down what the list looks like after each step. Otherwise, you'll do what I was tempted to do and say X is 1. So it's, I was looking at the original list as I was going, and not at the new list that was created after the first go through of the for loop. And it's easy to get stuck in that, where you're looking at the original list rather than the new list that's being modified as you go through the loop. All right, so that is, these are the kinds of things. Let me see, there's one more example I wanted to give you. Couple down here, I think. All right, so do a little list comprehension, print the list. What's going to print?
Yeah, spelling on print.
So what's going to print? The value of I is going to go in range 5. So the value of I is going to be 0 to 4. So that means that what actually gets put into the list is just 1 greater than that. So it'll be 1 through 5. So now, how about that? And what is
What?
what's that?
1, 2, 3, 4.
4 and 1.
Well, it's X for X in range minus 2, 0. What does that produce? It's, remember, range can have a starting value and an ending value. No reason why you can't start with a negative number.
So 3, which
So
would
we're
be
going to go from minus 2, minus 1. Yeah, that's what we're going to produce.
1, 2, 3, 4.
Minus 2 and minus 1. Right? Because range, if you don't give it, if you give it two values, the first value is what number to start with, and the second value is the number to end with, but not including that number. So minus 2, minus 1, and because it goes up to but not including the second value. Okay. What if I did? What's that going to produce?
In increments of 2, right?
Yeah. So, well, it shows up here, doesn't it?
Oh, I didn't know that.
5, 7, 9. So yeah, every other number. So remember, that's the third number in the range statement, if it exists, is the step value. dang it. What if I did that?
Does it just reverse the list? I don't know.
Yeah, in this case, actually, it's going to throw an error because you can't, or it may not throw an error, it might just create an empty, it'll create an empty list. Because you can't step -1 when the starting value is 1 and the ending value is 10. You can't go backwards. In order for me to make that work, I would need to just reverse those numbers. 10 down to 1. Okay, now it'll give me the numbers 10 to 2, starting from 10 going down to 2. Right up there. So remember, having a negative in the step value is only valid. Well, it didn't create an error, it just created an empty list. But if you wanted it to do what, what the intention was to reverse the numbers, you have to make sure your starting value is greater than your ending value. Okay, last one, I think, yeah.
What does it actually do if it doesn't throw an error? What is, like, if you run it through the debugger, what is it? But
It didn't do anything. The range basically said there is no range. It produced nothing. So the list just ends up being empty because nothing was generated by the range function.
trying to figure out what the logic was of thinking,
Yeah.
it doesn't produce an error, but it produces nothing.
So what does this produce?
Three lists that say A, B, and C.
Yeah, just 3 lists ABC right up here. So when I say print, well, let me copy this so I don't typo it. So what is that going to give me?
Just one list of ABC.
B.
Remember, I've got 2 subscripts, so it's going to, the first one points to one of the lists inside the bigger list. The second one points to an element of the inner list. So sub 1 points to this inner list, the second inner list. And then sub 1 of that points to the middle element, the B. Okay, because L1, again, L1 sub 1 equals ABC, but L1, and then looking at the one index value, that points right there. Except that I didn't capitalize my L. So how about this? What's that going to do? Let me print it.
A.
An
There's
error
no-
message.
There's no.
Oh.
Right, because
Why do I always forget about the 0?
yeah, you forget about the 0. So yeah, get that into your head. You're going to need it for the test. So yeah, that will throw an error because I'm trying to reference a value that doesn't exist, because the third index value 0, 1, 2 would be out in Never Never Land. So, and you actually do one of the questions on the test. I can tell you which one, because there's a couple that have it as an option that the program throws an error. One of them, that's the correct answer in one of the questions that throws an error. Okay. Any questions on anything we went over, either in the curriculum or on these preparing for the test.
Did we go over the threaded assignment or what that's going to be like?
For next time?
Was
For
that
next
next
week?
week?
Yeah.
Oh, okay.
So we didn't. No. Okay. So we jumped from 4 to 6A. Again, somewhere I lost assignment 5. I think I just I consolidated. I think I used to have a 5, 6, 7, 8, and then I just said, well, these 4 are all related to one another. So I should have started with 5, but I didn't. So don't be looking for an assignment 5. It doesn't exist. And I didn't want to go and change all the instructions to refer back to change it to 5A, B, C, and D. So there's going to be a series of 4 assignments that are all kind of build on this one. This one does sort of build on what you've been doing and what you did in assignment 4. But I really would, if I were you, to get the practice and to make sure that, when you start moving things around in a program, unless you're really solid with your logic, it's easy to get yourself confused. So that's why I'm saying I recommend starting from scratch. You don't have to, but I kind of recommend it. It's not a big, long program, or at least it's not too terribly long. But, use 4 as your sort of like your guide, but, start from the beginning and make sure you do it the way that, you would now compared to the way you might have done it a couple of weeks ago. So what you need to do here is you're going to get the following information from the user: the name and the IP address. Now with the name, again, if the user enters exit or the input is blank, the program should immediately exit. I would even say that if it's blank, or even if they just press spaces, which means that it's essentially blank, then it should exit. All right, and it should exit no matter how they type the word exit. Okay, so that means you're going to want to use these methods. Upper forces everything to uppercase, so you can always compare against an uppercase word. And strip is a new one that I don't know if I've gone over it or not, but strip basically gets rid of white space before and after the input. So to show you an example of what strip does, if I had a string, some spaces, okay, it stripped away the spaces in front and in back. Okay, and it's a good idea to use strip with the after the input, or even use it in line with the input if you want, because people will sometimes accidentally hit that space bar before they start typing, or they'll type and add a space. And if you do that, comparing exit to exit with a space, they're not the same. Okay, so if they enter a space at the beginning or the end, you want to help them out here and get rid of those spaces, because you know what they meant. So that's why I always use strip to clean up my data when I don't care about extraneous spaces.
I even figured out how to take it out of the middle.
That won't take it out of the middle, no.
No, but it doesn't. But I found a way. There is a way.
Yeah, you can replace multiple spaces with one space.
Yeah, I can't remember how I did it, but I made it work.
So what you can then do is say length of your input, whatever it is, your name. Compare it to 0 after you've stripped. That way, if they hit enter, or if they just have, lean on the space bar and then hit enter, the length of the input will be 0. And if the length of the input is 0, it's the same, you want to assume that they are finished, okay, that they want to quit. So if they type exit, or they type nothing, or if they type just white space, it should all be treated as they want to quit. Okay, so that's what we're talking about here. Okay, and then the IP address, we are going to validate the IP address, and we're not only going to make sure that the number that they entered for each octet is a valid number. So we want to look for a valid class A, which means the first octet has to be between 1 and 126. 127 is technically a class A, but 127 is the loopback, and it's not an address that we would normally want to be sending a packet to. So we want to look for 1 to 126 for the first octet, and 0 to 255, or for class A, I'm sorry, only if it's class A. Do we want to look at 1 to 126, and then up to 223 for the other classes. Okay, and then for the other octets can be 0 to 255. The thing is what if they type in a non-numeric value? That's where you want to test each octet. After you do the split, you want to test each octet to make sure it's numeric. Okay, and if it's not, then you want them print a message and tell them to re-enter the address. Okay, so you don't just quit or exit. You're going to basically do a loop and say, until you get this IP address, valid, I'm going to keep asking you. And so until they get a valid IP address entered, you're going to keep asking them. Once they do it, or get a valid IP address entered, then they're going to print out what the class is, what the address is. Okay, and we want, when you print out the address, we don't want the list version that you created with split. We want the string version that the user entered. Okay, and that's what the first assignment does. Okay, so what's different here, we're not going to get the port, because I'm going to add that, because you're going to validate the port number too. What's different here is we're doing a little bit more validation, and for the IP address, we're not just going to give up if they enter an invalid one. We're going to keep asking them until a valid one is entered. Okay, and it's going to be graded on these 4 factors. Most important one, does it work as described? I want variable names to be descriptive of the contents that they hold. Okay, if you're just doing a for loop in a program, and it's just really used to iterate through something, and the value of the counter variable isn't important, you could just use like I or X or whatever. That doesn't have to be descriptive if what's going into that variable is really just a counter of some sort to get through a loop. But otherwise, in this case, almost all the variables, if not all of them, are holding something important to the program. So they should be descriptive. The prompt should be good. In other words, the prompt should say not only what you're expecting from the user, but in what format, and then in the case of the name, how they get out of the program. If they are done and they don't want to do it anymore. and then some decent comments. You don't need to go overboard with comments, but I would say, in a program like this, 3 to 5 comments is probably sufficient. All right. So that's this week's threaded. The only other is using a list comprehension. It's just a pretty easy list comprehension. It's basically going to help you with the program because you're going to get, again, it's dealing with an IP address. And then you're using a list comprehension to convert each octet, which is entered as a string, to convert it to an integer. And you can use that exact same logic in the program in the threaded assignment. Okay. All right, any other questions or anything that you want me to go over that from last week, or anything you're not getting that you want me to do a quick go over on? See, and you guys are the best ones, honestly. I mean, I remember these names, and you guys are all sorry, I say guys, Jennifer's here too, but only people that have their cameras on are guys. So, but what I'm seeing is that I wish some of the people that aren't doing as well would show up for these. But that's the way it goes. So any questions? Take your time with that test. It's a little frustrating. I just went through it and I was like, yeah, this is going to be a challenge, especially for those that haven't been playing around with this stuff. If doing just the assignments really isn't good enough, because to get you well practiced, except for a couple of you that have had some programming experience, to really get enough practice so that you really can trace through a program with confidence and know what it's doing, you got to play around with this stuff on your own a little bit beyond the assignments, I think. Unless you're just really better than I am as far as picking this stuff up. And I suspect that some of you are doing that because some of you are putting out some good stuff. So, and going finding your own way to do things that even some ways I wouldn't have thought of. So that's always a good sign that you're, paying attention and trying to figure out how to do things beyond the prescribed way. Okay, well, if there's nothing else, then, and if there is, I changed my office hours this week because I figured for this class, it might be good to have an office hour the day after we meet, so that, if you didn't want to ask a question during the Zoom meeting, you could, hit me up at office hours. I usually don't have anybody in there. Last week I did have 3 people show up, but more the merrier, because you'll probably learn something from what they want to go over. But 10:30 to 1, it's on the home page here what the link is. So yeah, so change it to, instead of Monday, Wednesday, Monday and Thursday, 10:30 to 1. And you could call me too if you don't want to Zoom. It's my office number, which we now have Zoom phone. So my office number actually pops up as Zoom session. You can be on a regular telephone, but pops up a Zoom session for me. All right, then I guess we'll catch you when I see you next, either office hours, an appointment. You can always ask for an appointment for a different time than my office hours, and I'll try to work it out. Or I'll see you next week.